Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So in our today's lesson, we will discuss about the calculation of partial pressure of gases, that how we can calculate the partial pressure of the gas that are present in the mixture. For this purpose, if we have the partial pressure of a gas in a mixture, then we can calculate it by using this equation, which is PA is equal to the XA into P total, where we have the PA, it is the partial pressure of the gas A in the mixture, and XA, it is the mole fraction. And how we can write the mole fraction? We can write the mole fraction where number of moles of A and the total number of moles of the gas. So Na over Nt, it is the mole fraction, which is denoted by X, and P total, it is the total pressure of the mixture of the gas. What is the total pressure that has been exerted by the mixture of different gases? So for all these calculation, if we have the mixture of gas, and in this mixture, if we are provided with the mass of gas, and if we are provided with moles of gas, and we know the total pressure of the gas, then we can calculate the partial pressure of the gas that is present in the mixture. So how we can derivate this equation? For this purpose, let's have a look on the example. For this calculation, we have to just suppose here we have the mixture of gas A. We have mixture in which we have gas A and we have gas B in two containers. So the mixture is enclosed in a container and it is having the volume V, and the total pressure over there we have it is 1 atm. Then the number of moles of gas A and B is denoted by where we have gas A and its number of moles is equal to Na, and if we have gas B, its number of moles is equal to Nb. So how we can maintain a simple relationship between it? The general gas equation, we have PV is equal to nRT. So this is the equation. If we have the mixture of gases, then we can write it as PT is equal to NTR into T. This is for mixture of the gas. After that, for the gas A, we can write it PAV is equal to NAR into T. This is for gas A. Then we have for gas B, which is PB to V is equal to NBR into T, and for gas B. Now we will divide the two equations, which is the equation number 1 and this is the equation number 2 and this is the equation number 3. So in the first step we have to divide the equation number 1 and 2. After dividing, we just have the equation PA V over PT to V, which is equal to NT R into T and divided by NT R into T. So here we have just seen by cancelling the same, the result that we gain, it is PA over PT, which is equal to NT NA over NT. So here we have to calculate the partial pressure of the gas A. So partial pressure of gas A is equal to Na over Nt multiplied by Pt, where Na over Nt, it is the mole fraction of gas A, and it can be denoted as XA. So PA is equal to XA into PT. So this is the simple calculation of partial pressure of the gas. Likewise, we can also write for the gas B. So gas B is partial pressure is PB. It is equal to the mole fraction of number of moles of gas B multiplied by the total pressure. So the partial pressure of any gas is the mole fraction of that gas and multiply it with the total pressure of the mixture of the gas. So one thing that you have to keep remember that mole fraction of any gas in the mixture, it must be less than unity. So the mole fraction must be less than unity in any gas. Next we have an example for this partial pressure. Here if we have a mixture of hydrogen, helium and methane gases, so we have just three gases. They are occupying a vessel. The volume is 13 dm cube and temperature is 37 degrees Celsius and pressure is 1 atmospheric pressure, and the mass of the gases in which we have hydrogen and helium, it is 0.8 gram and 0.12 gram. So respectively, we have to calculate the pressure in torr of each gas in the mixture. So how we can calculate this? We have to calculate first of all its number of moles. So the given data here we have, it is volume of gas, volume of the mixture of the gases, and the volume we have 13 dm cube. And the second thing we have temperature, which is 37 degrees Celsius. By adding 273 we gain 310 Kelvin. And the third thing we have, it is the pressure of mixture of the gas, which is 1 atm. First of all, we have to calculate the total number of moles that are present in the mixture of the gas. So total number of moles we can calculate it by applying the different conditions, which is PV is equal to nRT. So here we have to calculate the number of moles. So by rearranging this equation, we gain N is equal to PV over RT. And here we have all these values. N is equal to pressure, we have 1 atm, and the volume of the gas we have 13 dm cube, which is given, divided by the general gas constant, and we apply the unit of SI, dm cube per Kelvin per mole and atm. Multiply it with the temperature, which is 310 Kelvin. So here the number of moles of the total gas which is present, it is 0.51 moles. So this is the total number of moles of the gases, and we have three gases: hydrogen, helium and methane. So we have here the total number of moles, which is denoted by NT. Then we will calculate the moles of the gases. So for the further calculation, we have to calculate the number of moles. So moles of hydrogen, we have its mass, and the molar mass of hydrogen is 2. So 0.8 grams divided by molar mass 2, we calculate its mole 0.40 moles. And then we have moles of helium. Its mass is 0.12 gram divided by the molar mass of helium, which is 4 gram per mole, and its moles we have 0.03. At the end, we don't have the mass of the methane. So how we can calculate its moles, we can calculate it by the difference method. And the difference method over there we have moles of methane. It is equal to total moles subtracting moles of hydrogen and moles of helium. So we will apply this. So the moles of CH4 is equal to total moles, and the value of total moles we have 0.51, subtracting the moles of hydrogen, which is 0.40, and subtracting the moles of helium, and moles of helium we have 0.03. So at the end, the moles of methane is equal to 0.084. So here we have the moles of all the gases. Then we calculate the mole fraction of these gases. So how we can calculate the mole fraction? So mole fraction of hydrogen, which is XH2, it is equal to total number of moles of hydrogen, which is 0.40, and the moles of the gas 0.51. It is equal to 0.784. Then we have moles of helium, or the mole fraction of helium, which is X into He. It is equal to 0.03 moles of helium, and total moles we have 0.51, and the answer we have 0.058. Then we have to calculate the mole fraction of methane, which is CH4. It is equal to total moles of methane is 0.084 divided by total moles 0.51, and we gain 0.164. So this is a simple mole fraction of the gases. Now we have to calculate their partial pressure. For the calculation of the partial pressure, we have to put over there. So the partial pressure of hydrogen, it is equal to the moles of hydrogen into the total pressure, which is 0.776 multiplied by 1. So we have 0.776 atm. Then we have the partial pressure of helium, which is equal to number mole fraction of helium multiplied by the total volume, and the mole fraction of helium we have 0.058 multiplied by 1 atm. It is equal to the total pressure, which is almost 0.058. And then we have the partial pressure of methane, which is equal to the mole fraction of methane multiply the total pressure, and the mole fraction of methane we have 0.164 multiplied by 1 atm. It is equal to 0.164 atm. So this is the pressure applied by the different gases. I hope you guys understand, and if you have any queries, you may ask me about that. And the next topic that we will discuss, it is the diffusion and effusion. So for that time, you guys have a good day, and Allah Hafiz.